what he is doing right now is working on state-of-the-art projects. And in association with Skill-Lync, now there is an opportunity for you guys to come and work with Mohammed in one of these projects. So I'm basically sharing my screen. So these are 5 projects that he has handpicked, and in order to kind of for this 12-week research program. So what is this 12-week research program? So one of the ways that we think about education is working on projects allows you to learn at a faster pace and also allows you to learn what is required in the industry. And that's why what we have done with this particular research project is basically have associations with people like Mohammed who can come in and help kind of take this research forward with people who with candidates and students who want to kind of work on these research, who do not get an opportunity to work on these research unless and until they are working in some of the top companies, or they are graduate students of, say, probably San Jose State University or any other US or European university. So that is what we are kind of bringing into the table, right? This is a 12-week program. Only 5 participants will be allowed in this program. Each one of the participants will basically work on one project. So this is what I wanted to kind of share my screen and explain. And if you guys want more details about this, you can basically check out in the chat box. I'll just posted this link in the chat box, and detailed understanding of those projects are also given below. So you can basically take a look at what are all the aspects that students will be working on in these projects. Right. So this is a quick summary of the research project. So I'll kind of stop my share and kind of take it back to Mohammed. And
And if I wanna add a couple of things to what you said here, sorry. Um, in working with my students and then observing their performance and their job prospects, it's slightly correlated to their GPA, but it's very highly correlated their job prospects to the work that they put into their projects. It's really, I think, I also, when I think about myself when I was an undergraduate student, you think the GPA is the most important thing. But then when you graduate and when you enter the workforce, you find that all the questions they are asking you is about what kind of experience you have, what kind of projects you worked on, did you work on, and what kind of hands-on experience, what kind of simulation tools you can work on, what design experience you have. And so these projects are basically what I do in my university, and what I'm trying to do here also is to design projects that will give you the maximum exposure and the right amount of depth that you need into one of these topics, so that you can have that in your resume, and that's going to be the main topic of discussion with your potential recruiters.
Absolutely, and this is something that we have witnessed as well. We have trained around 10,000 students right now, and and the usually the interview questions are based out of the projects that they did and not based on concepts that they know. So the conversational starting point is basically what projects that they do, rather than and what happens that something that we have witnessed is people who have high GPA, say four pointer, but they don't have projects in their resume. What happens is then that since the projects are not present in the resume, the conversation starter becomes topics. And say, for example, if those topics are going to be power converter, and if you are the interviewer, and while I might know power converters from my theoretical understanding, you might know power converters from a very practical understanding. And a lot of the questions that you are going to ask me as an interviewer from a practical understanding point, I'm not going to, even if I learned a lot of theory, I'm not going to be able to answer. And we have practically witnessed a lot of this happen. And that's why we made sure, so all our courses are baked in with at least 3 to 4 projects. And one of the reasons for us to kind of come in and do this research project a little different from our coursework. So in our coursework, we teach and then do a project. And this research project is more of a do the project directly kind of thing. And the reason we kind of are doing this right now is that understanding of the most important thing is one really good project or two really good projects in your resume. All right, and that's what we are trying to bring in. And thank you for kind of thinking about your undergrad. Right now, I also want to kind of walk us through your pathway. And for example, how did you think about power converters? And how did the research that you're doing right now, what was the pathway to it from your undergrad to what you're doing right now?
Yeah, so during my undergrad, my university, you have to specialize early on between communications, power and energy, or communications, or networking, and so on. So I read about these topics a little bit, and I was always more fascinated by things in electrical energy that you can actually kind of feel, that you're not gonna see it, but you have a strong feeling to it. When I tell you the power that we're converting 400 volt to 12 volt, it's easily understandable to me. And I really like that. I took preliminary courses in power electronics, and I like the area. So I decided to pursue my career in power, in the power field in electrical engineering. Then I started my master and my PhD degrees in Ohio. It was at the University of Akron with Doctors Malik Al-Buluk, Dr. Irma Souzer. Both of them are pioneers in this field. And with them, we started my master degree with a solar converter project. The idea of it was how to convert solar power efficiently, and how to combat problems of partial shading and things like that. We're able to, and the main thing for me in the master project was that I was able to actually fully design, fully simulate, and fully design a power converter. And then after that in the lab, I was able to build the hardware and test it. So that's basically, that was my main experience. And after that, I started getting job offers after my master degree, even though I didn't really apply because I wanted to do a PhD. And then I decided to do the PhD. And in my PhD, it was a mix between solar power and the electric vehicle, and the electric vehicle charging also. So I was building an electric vehicle charging station using solar energy plus battery storage. So this topic gave me great exposure to all of these topics: how to integrate solar power with battery, how to charge your electric vehicles, which I hope would be another project for another time that would be focusing just on the charging, and then how to fix the electric vehicle drivetrain, how to go from the battery to the motor, and so on. And with electric vehicle charging, you learn about conductive charging and wireless charging and all of that. So yeah, because of that, basically was my work for about 5 years. So that gave me the exposure into this area. And then when I accepted my offer, I graduated on a Friday. I started working at San Jose State University on a Monday. I just had a weekend off. So as soon as I started working in the university, my main goal was to get my research aligned with the industry. And I remember that in the first semester, my work was to develop a list of the biggest industrial players in the area. And they are not you're not only your most popular names. It's not only Texas Instruments and Analog Devices and Tesla. There are a lot of companies, but because they are B2B, we don't really know a lot about them. So I started approaching these companies. I had tons of meetings with them and trying to get feedback from them, trying to get a feel from them for what research challenges they are facing. And I'm hoping that my lab will be able to answer some of these challenges. And based on that, we developed our lab, our Center for Power Electronic Converters. And I currently have, at any point of time, I'm averaging around 30 to 60 students in the lab that I'm advising, and we started having like a streamline of how to advise the students and what projects they are working on and how students are training one another. And so we have like 5 or 6 big projects that are all going in parallel now, and so on. So that's how I am here right now.
And did I hear it correct? Did you say 30 to 60 or 13 to 16?
No, 30 to 60, 30 to 60.
Oh, that's a
That's
huge section.
between, yeah, but that's between master, between graduate students and undergraduate students. Um, so because it's really hard, what I did is that I developed a system that in every project you're going to have some graduate and some undergraduate. Some of them are in their first semester, some of them are in their second, some of them are in their third, in their fourth, and they're going to kind of train one another. And then every week I meet with every project team and I go through their what they did. So that enables me an ability to, I'm still able to manage all of this and supervise all the students, but they are also able to interact with one another more frequently.
Great. Hey, in continuation to that, like that's a very good segue. So you say in a particular project, you have a mixture of students. So in this Skill-Lync research projects that you're proposing, is there any prerequisites? That's the first question that a lot of people ask. And if there are any prerequisites, what are them?
What's the second question?
If there are any prerequisites, what are those prerequisites?
Okay, cool. So I would say it would be really helpful. I don't know if the course that I taught is already available for everyone, the power converters course, but I think it's called design and simulation of power converters. But I think if it's available, then that's a great start for anyone who would like to do this project. However, if someone didn't take the course, I don't know if they saw the timeline yet, but when you guys see the timeline that I built for these projects, you're gonna find there, I think there is 1 to 2 weeks that you're basically revising material. So I'm gonna be handpicking material and telling you that this is the material that you need to start working on and revise. And if you didn't take it before, then you're gonna have to take it and understand it to be able to catch up. So this material, you can do it on your own, or if you took the course, and that's going to give you a head start. That's it. Other than that, so I would say the course is a soft prerequisite. It's not really a hard one because in the 5 projects that I assigned, there are different skills that you need, and I'll try to work with you to make sure that you're going to have these skills prior to going deep into the project.
Any tools that you would recommend, say MATLAB, Simulink, or something?
Yeah, so definitely. So we're gonna start. We're gonna do 2 things. So every project is gonna start in the same manner. At the beginning, you're gonna review a little bit. You're gonna do some revision. Then after that, you're gonna do some literature review, which is a little bit different. That in literature review, you start in the revision. The first one, you're just trying to understand the concepts. In the literature review, you're trying to understand the state of the art. And then after that, we're gonna try to build a behavioral simulation. In behavioral simulations, I'm planning to stick with MATLAB Simulink. And if you never used it, I'll help you through that. But we're planning to stick with MATLAB Simulink because of the variety of tools that it can give us and the flexibility that we can have in controlling our converters there. And then after that, if that's successful, then the next stage would be to start building your schematics. And that's what we call SPICE simulations or detailed schematic simulations. So there you're gonna need to use, there are different softwares that you can use. One of them is LT-SPICE, which I think is the most popular because it's free and really it's accessible to everyone. There is another one called TINA. It's provided by Texas Instruments. It's also free. And then there is a third one that became recently free for students only, which is ORCAD. So ORCAD, they have an academic license. So if you just even Google ORCAD academic license, you're gonna find a page that you just have to provide information that you are a student, and then they should be able to provide you with an academic license. And I would advise you to start doing that early on if you're planning to join the project, because it might take 1 week to 2 weeks to get this license on your laptop. But it's very valuable. After you graduate, if you're trying to get ORCAD, it's going to cost you hundreds of dollars, if not thousands. So it's very valuable if you can put your hands on it now. Yeah, that's basically it for this project. Yeah, I think that's most probably that's where we're going to stick with. And then also at some point, you're going to find the 5 projects that I planned are kind of connected together. All of them are building an electric vehicle drivetrain together. So you're gonna, at some point, the 5 students who are gonna work with me, we're gonna start coming together and trying to integrate our work, so that at the end of the day, we're having a fully operational electric vehicle drivetrain with all of its converters, with all of its inverters, with all of its battery management system and sensors and schematics, you know? So that's the plan at the end. If we can have that, that's going to be a huge achievement for the whole group to be able to build such a system. So that's why I wanted to unify the software tools that we're going to use, so that when we integrate them together, we can easily do that.